giving this presentation today to show you a little bit of the potential and power of a distributed software architecture using serverless, cloud-native design, as well as microservices and dashboards. My background is computer science. I have a bachelor in CS, a master in engineering, automation, and robotics, and an MBA focused in the software engineering and IT management. Back in 2020, we created a startup called Qonteo, specialized in biometric technologies, image processing, and data analytics. In a period of 3 months, with no money in our pockets, we received requests to demonstrate and pilot our solutions, and back then, we had to decide what would be our software infrastructure to support our ideas, with a minimalistic approach, using the minimal resources as possible. How could we deal with blobs and real-time video streams, tons of metadata to process, keeping low costs, while we could easily escalate our demos through multiple clients? The solution, of course, was aimed for open source, but which ones would give us such flexibility? Plus, in case everything goes wrong, how wouldn't we end up with a huge legacy, licenses, and loans to pay off? I'm going to present a video that summarizes quite well our open source solutions involving image processing, data analytics, and technology consultancy. Qonteo means counting in Spanish, with a proposital misspelled C with Q in order to build our brand name. Counting, quantifying, measuring, analyzing, indicating, processing, presenting, and the list goes on. They are all about data and how pure ones and zeros become such a valuable information these days. Whether for marketing or security, numbers are very important KPIs to keep and catalyze business decisions. And that's why we started Qonteo. That's why we started counting, processing, analyzing, and presenting, converting quantified and qualified data to high-value business information. Our team is spread among several countries, including Argentina, Brazil, Colombia, Ecuador, India, Peru, Spain, and United States. We plan globally and act locally. We work with local and regional markets to achieve results and customer satisfaction. The main goals are to increase revenue and reduce costs. Qonteo is not only about technology, but also how to make the most of its tools using cutting-edge techniques and innovative methods. We are here to show them the money. Our first client was a gas station where we installed 5 cameras, in which 3 were to track vehicles and 2 cameras to track persons. The goals were related to conversion and resource planning. We placed cameras filming vehicles entrance and exit, plus a third camera filming the highway. That way we could get conversion rates easily, such as how many cars get into the station versus the total of cars passing in the 60 lanes wide street. What's the peak of hour of the day? What is the most crowded day of the week? What was the average service time? Many other KPIs could come up depending on the client's needs and business dynamics. Other goals were related to marketing and staff planning. How many people get into the convenience store? Giving to the gas station the ability to send SMS messages with bonuses and product discounts to the register's frequent clients, based in the profile once their faces get recognized. Plus, how many staff people were working, tracking their shifts, and planning the team presence in the peak hours. And based on that, the managers could act accordingly. Again, the gas station had 5 cameras installed, which 3 cameras were to track vehicles and 2 cameras to track persons, and the data network traffic for vehicles and facial recognition was around 5,000 requests per day for vehicles and 8,000 requests per day for persons. A request means to send blob to image engines, collect metadata, store it, and respond successfully. The second client was a shopping mall. In this case, goals were related to marketing, security, as well as staff planning. We built a few business indicators, including how many people entering and exit from the mall, which places and areas they were passing by, how long was the entire journey of a person in the mall, with a plus of giving to the mall ability to send SMS messages with bonus and product discounts to the registered frequent customers, based in their profile once their faces get recognized by the cameras. Plus, how many staff people were working, tracking their shifts, and planning the team presence in the peak hours. We also offer the ability to replace their security DVRs and NVRs, digital and network video recorders. For that project, we initially started by counting people, simple as that. Later on, the client has asked to enhance the systems, adding features such as people tracking and security supervision. The shopping mall specifically had data network traffic for facial recognition only, and it was around 18,000 requests per day. Our third client was a medical clinic. They required us to build an authentication method for their conference rooms using facial recognition. That way, they could secure their rooms, making sure that only authorized people were watching the real-time meetings, as well as they had a way to confirm now that the people who booked the appointment was the very same attending to the sessions. Data network traffic was as small as 200 requests per day only. That was our baby project. Overall, for the 3 projects, the total was 80,000 requests per day to insert data, and approximately 2,000 requests to serve the front-end dashboards and present the KPIs. Within time passing and resources loading up, we started to face delays in query responses. Then we looked at our backend and database to start optimizations, such as API caching and memoizing, database vacuum, database indexing, and auxiliary tables to store totals. Restarting Navi server to clean up old cache usage and routines wasn't necessary. even because a good feature of Navi server was that once the procedure was loaded and cache was generated, the best way to keep it running fast was to keep it alive as long as possible. We also looked at the few database indicators such as response time and query performance, the average response time per query, database events, query out throughput, work done by the database server over a unit of time such as per second, per hour. We also look at open connections, buffer, pool usage, and errors. The whole setup involved this bucket of software and framework presented in the slide, consisted in a few open source nuggets. Operating systems such as Debian, Ubuntu, Raspbian, and CentOS, object and relational databases involving PostgreSQL, MySQL, Aerospike, and InfluxDB, web servers such as Navi server has the backend server, Nginx has the proxy server, Node.js has the front-end server. Programming frameworks and libraries stacks such as OpenCV, OpenACS, TCL/TK, Python, React.js, React Native, and JavaScript. The same overall architecture was applied to 4 clients simultaneously. The architecture we drew back then was similar to this diagram. VPSs containing server-side applications such as OpenACS and PostgreSQL were installed to store and serve metadata from visual recognition engines such as AWS Recognition and Google Vision to dashboards with analytical information and business KPIs to enhance our clients' decisions. So, once an image stream was captured by the camera, it was sent to the web server, for instance the robust Navi server, and from there, the same image was sent again to the image recognition and process engines in the cloud, which returned the metadata back to Navi server. The metadata was then processed, normalized, and stored as a content item in the content data model. Lastly, but not least, once requested, Navi server would send the processed data to a front-end Node.js stack website in order to present those business KPIs in a stylish and well-designed dashboard. The workflow consisted in framing, filing, uploading, processing, and presenting. Again, camera stream is converted to frames which were captured by OpenCV and saved as blob image files, which were sent to the image recognition engines remotely in the clouds, and from there, image metadata was sent back and stored in the DB servers. And lastly, presented in the Node.js and React.js front-end dashboards. We used Raspberry Pis locally running OpenCV to convert frames to images containing recognized vehicles and faces only and save them locally. That way, it would reduce the number of requests and network traffic, sending only an image within a positive match to the remote servers. In order to normalize and store metadata in such a way that would support individualization and tracking without losing performance, we created vehicles and faces as different objects in different content types, called Qt face and Qt vehicle. The ability for individualizing and tracking was applied by generating multiple revisions of the same object or item, so that if an auto passed by a camera, its metadata such as plate, model, and category was compared against a database, and if the item had been registered previously, a new revision was created with a new date, time, and localization data, such as country, camera, and gas station code. To vehicles, metadata was consisted in plate number, category, model, instant, date time, and localization, such as country, camera ID, and gas station code. Regarding faces, Metadata was consistent in age, gender, face number properties such as dimension, width, length, distance of the eyes, mouth, nose, ears, and forehead. We could even get emotions from the faces. That way we could advertise feelings such as happiness, sadness, and so on and so forth. We also capture instant date and time in localization for tracking purposes, such as country, camera ID, and store code and store name. All developed solutions were LGPD compliant, meaning the data is totally anonymized and we don't store any critical data which could possibly relate to a person or a vehicle and its owner. However, depending on the client's needs, we could do what the otherwise. For example, to replace DVRs and NVRs, recordings will be stored with all mandatory security permissions, constraints, and regulations if necessary. Qonteo made data mining and analytics easy to our clients. We make the heavy lifting lighter for them. We connect video IP cameras to our online platform, and depending on your plan or contract service, we start collecting, processing, and presenting data to you. Let's watch a quick video that shows us quite well what Qonteo is capable of doing for our business clients. Indeed, we have plenty of future enhancements ahead to cover. We would like to explore the usage of PostgreSQL and OpenSSL clustering in order to scale up our applications to the industrial market. We would love to enhance our automation, machine learning, and training algorithms in order to offer a better and customized products without the need or support of any vision engine such as AWS Recognition or Google Vision to generate metadata. We also would like to explore the cameras which generate metadata themselves so that we could scale image recognition and processing solutions as well as to wrap them to new sources and applications in order to contribute with the open source community. Well, time passes in a blink, don't it? I'd like to thank Qonteo for all the intense experience I've lived during these 2 years. I'd like to thank React Native Summit 2002 and Linux Foundation for giving this opportunity to present our project and put Qonteo in the map for open source and cutting-edge technologies. Lastly, but far from being the least, I'd like to thank the whole open source software community because without them, none of that would have been possible. Thank you everyone, and if you have any questions, I would be glad to answer if possible.